Hey, welcome back to week 5, lesson 2. Today we're going to be looking at nuclear decay reactions. You have an assignment in Google Classroom to complete with nuclear decay reactions. So we're going to head on over, excuse me, to nuclear decay and take a look at Google Classroom here. Today we've got nuclear decay. Attached is a copy of a screenshot that we're going to be taking a look at. I've hyperlinked ptable.com, which gives you a periodic table to use for these nuclear decay um, reactions. And then this assignment here is the actual worksheet for the assignment on nuclear decay that you can click and open and type in your answers for your assignment on nuclear decay. So let's go ahead and take a look at the screenshot here, and we'll walk through a few of these to help get you started on the assignment. So our assignment, or the examples, is looking at copper for this first one. This is copper 65, right? Here's the mass number, and it's undergoing decay and becoming cobalt. Okay, so your options on this assignment are either alpha decay, which is He4/2, mass being 4, atomic number, or the number of protons being 2. The second option is beta particle, or beta decay, which is represented by the symbol lowercase e, mass value of 0, atomic number of -1. So these are your two options of particles to complete these equations. And if we look at the atomic number, which is the bottom number here on copper, you can see that copper is atomic number 29. We can also jump over to the periodic table here and verify that copper is atomic number 29. So if we were to complete this one for number 1 down below here, which answer choice would you choose? Alpha or beta? Okay, and to help answer this question for you, you need to look at these bottom atomic numbers of going from 29 down to 27. And just like balancing an equation, the arrow is treated as an equal sign. So what is on the left side over here for the mass and the atomic number of copper has to equal the total of what is on the right-hand side of the arrow for the atomic number of the unknown and the atomic number 27. So those added together equal 29. So 29 minus 27 is going to equal 2 for our atomic number. So therefore we know that the decay type is going to be this alpha particle, 4/2 He. So I'll go ahead and type that on the screen here. So A would equal 4, blank B in number 1 would equal 2, and then letter C would equal He, the symbol for helium, the element helium. Okay, so these are your answers for the blanks for this example. And then to continue to the last blank, letter D on cobalt, right? If A is 4, 65 minus 4 would give us the value for the mass of cobalt. So 65 minus 4 is going to equal 61. Okay, for letter D over here. Now, number 2 works the same way. What happened? So on number 2, we have A, B, and C that we need to figure out. So if we look at number 2, we've got 214 going down to 210. We've got an atomic number of 84 going down to 82. So of these two options down here at the bottom, 4 over 2 or 0 over -1, it's definitely going to be the 4 over 2 because our mass is dropping by 4 from 214 to 210. And then the atomic number is dropping by 2 from 84 down to 82. So letter A's answer on number 2 over here is going to be 4. B is going to be 2. And then our symbol for the alpha particle is capital H, lowercase e for helium. So it's just like number 1 in this case for your answers. With number 3, there's more unknowns. So number 3, notice the atomic number is not given for the symbol Rn. So we can jump over to the periodic table. And you can find Rn on the periodic table, which is radon. And Rn has an atomic number of 86. Okay, so 86 is the atomic number for the symbol Rn. So A will equal 86. Okay. And then continuing on to letter B is going to equal 2, correct? Because the 4 for the mass kind of hints to the direction of it being an alpha particle, 4 over 2 He, right? So B is going to be 2, and C is going to be He, the symbol for an alpha particle or a helium nucleus. Continuing on to our second portion over here, if we know this is 4 over 2 He, right, we can subtract 4 from the alpha particle from the total of 222. So 222 minus 4 makes letter D 218. And again, looking at these atomic numbers going across the bottom to figure out what letter E is over here, remember that letter A was 86, and then the alpha particle decayed off of that, taking 2 protons with it. So 86 minus 2 is going to equal 84. Okay. So letter E is atomic number 84. So one of the clues to finding letter F, now the last one here, is to take this atomic number and find the symbol for atomic number 84. So if we jump over to the periodic table and go down to atomic number 84, the symbol for that is PO, capital P, lowercase o, for the element polonium. Okay, so PO, capital P, lowercase o, gives us this symbol that we need for letter F. All right, let's move on to number 4. Number 4 is a little more challenging one as well. So number 4, we're starting with letter A, which is the mass value, right? And we don't know that at this point. So we're going to save that and come back to it. We'll just mark it down here for our answers. And we can come back to that one when we have some more information that will help us in figuring out what letter A is. So we do know for this first element that it is atomic number 90. So knowing that it's atomic number 90, we can jump over to our periodic table. We can go down in the periodic table to atomic number 90, which is the element TH for thorium. Okay, so we want to put TH for letter B, capital T, lowercase h for the element thorium. That would go in this blank here for number 4. And then continuing on, we know our last symbol for the element Ra. We know its mass is 226. Okay, so Ra we can find, since we know the symbol Ra, we can skip to letter F and we can look for the symbol Ra on our periodic table. And Ra, did you find it? It's atomic number 88 down here on the lower left. Okay, so we know that the atomic number, the bottom value for that blank for letter F, is 88. Okay, so now we know a couple things that will help clue us in so that we can move on, because we know that we still need letter D and we need letter E as well. Okay. And so going back to letter D, because we know the atomic number 90, we figured out that the atomic number for Ra is 88. So now we have 90 dropping down to 88. So we must be losing 2 for letter D. Okay, so 2 is the atomic number for letter D. We also know that from this, we have the only option with an atomic number of 2 for a decay particle is this alpha particle down here, 4 over 2He. So now that we know the bottom number, or the atomic number, is 2, we know that the top number must be 4 for the mass value, and the symbol for blank letter E is now capital H, lowercase e. Right? So now we have all of them except letter A. So if we go back to letter A, we know that 226 plus the value for letter C will equal letter A. The value for letter C is 4 down here on the bottom of the Google Doc. So you can see letter C, number 4, plus 226 would equal 230 if we combine the 4 with the 226. So letter A is a mass of 230. So go with what you know. Use a periodic table to help you find out what you can know, like the atomic numbers and the symbols. The mass numbers, just be aware the mass numbers do not follow the periodic table per se, because remember we're looking at isotopes. So there can be multiple isotopes of the same element, and that means it could have a different mass because each isotope has a different mass number. So the mass won't necessarily follow what's on the periodic table. All right, just so you're aware of that. So I hope that helps you get started and complete this worksheet for today's lesson on nuclear decay. And if you have any questions on the worksheet, please get with me via email or remind and let me know. I'll be glad to assist you in any way that I can. So I'll see you in the next lesson. Happy working on your nuclear decay.